Hi, I'm Julian Rodriguez, and me and my partner James Schenkelberg did a LabVIEW project for ETE 420 LabVIEW and Instrumentation. We decided to do a project that would control 2 motors by Quicksilver Control Incorporated using LabVIEW and a joystick. Here we have the joystick. It's just a potentiometer going from 0 to 5 volts on 2 axes. That is fed into the MIDAC and then into the VI. The VI sends the signals from that we pre-programmed. There are many sub-VIs that control the overall motor. My partner James Schenkelberg will go in depth into each one.
Using LabVIEW to control QCI motors. These are QCI motors. We're also going to be using the MIDAC, and we're going to be using a joystick with an X and a Y, or basically 2 pots, one in one dimension, the other in the other dimension. So the joystick is wired to the MIDAC, and we're using 0 to 5 volts across each pot, and then the center arm of the pot through a resistor, just so that nothing can short it out. One goes to analog 1 and the other to analog 2. This is the LabVIEW. This is the completed Control T, the complete LabVIEW program. Okay, so we will look at individual parts in a minute. Oh, and there's also a power supply going to the QCI motors that's maybe out of view, but it's up there. Now, first we'll start in continuous mode. Oh, you have to select COM6, and we'll get to the individual components in a minute. But right now in continuous mode, okay, I believe this will be the fastest of them both. This will be the slowest of them both. This is showing you what the joystick is seeing. One analog input 1 is one of them. The analog input 2, or 0, I'm sorry, is the other one. There's also a numeric thing. Now, we have a continuous mode and a discrete mode. In continuous mode, you see you go from going really fast, all in the same direction, and now moving diagonally, I'll reduce them both equally. So actually it looks like they're stopped, they're not. You'll see why this is used to select over in the block diagram. You'll see what it's controlling. And now if we click stop and then go to discrete mode, gotta pick the little hand, go to discrete mode, they will move in absolute, actually each time they move exactly 4 revolutions at differing speeds depending once again on the joystick input. So and you notice the numbers are different here. Now, what this continuous discrete step really does is it uses this case structure. If I turn on the light bulb, you'll see it next time through, and that will probably instantly see it went to straight lines through. So that does not add that additional 11 that now if I go to continuous mode next time through right in here, that will add 11. See, there you go. It adds 11 as it goes through. So it basically hops to a higher grouping in these 2 case structures that we'll get to in a minute. There's one other trick. In this continuous mode, you need a stop command. If I hit stop, it clicks this guy into, oh, there it goes. That will send out a 22 from here, which overrides the inputs from the joystick, and then we can look over here what a 22 does. Okay, so here is a case structure. Let's pick this upper one. There are 22 different cases. Using the joystick basically gets to every single one of those between the joystick and this switch. Gets to all of them except for that 22. The stop command comes into this case structure and forces a 22 out. The 22 one looks like this. That means send this to motor 16. See, one is named 16, one is named 17. The command is a command number 3, which means stop, and the -1 means stop instantaneously, not sort of like slow down or anything like that. That means stop wherever you are. So if you're going really fast and you hit that stop, it can be kind of violent, and I can show you that. Let's see. I'll turn off the light bulb so it goes faster. Let's get it going really fast, which would be this way. Now when I press stop right now, it'll violently stop. See? It says immediate. Anyways, all of the other commands in here, like let's randomly pick one, 18, the commands look like something like that. Now there's a lot of information. All this is a string of information that we're going to send to those motors. We'll look at how that works in a minute. But like this one, 18, and let's look at the same one then on this one and see that there's, oops, yeah. The only difference in that command and that command is that this one goes to number 16 and this one here goes to number 17. Otherwise it's the exact same command. This says a 15 command means move, a velocity move. This controls the amount of velocity, and the 00 means don't wait for any of your digital inputs signals to start, and don't wait for any of your digital inputs to stop. That's what the 0 and the 0. If you put numbers there, it could look for one of these inputs to either be used as a stop command or a start command. The negative means it's going to go counterclockwise. If we change this to a plus, it would go clockwise. Now we'll look at individual parts. Let's look at the joystick part. That's a good place to start. You see the little icon I built. Here's what it looks like. So there's stop, goes into the DAC assistant to use the DAC. What it does, if we looked in the input to that, or I'm sorry, the setup of that, it's looking at to read a voltage, which is, these are just voltage dividers on the joystick. So it takes the voltage and builds these views of it. We can run this by itself, and you can see it. And it's not running. Oh, it runs once now. That's right. So in its current mode, it runs one time, and you see as I move the joystick, you get different numbers. So I'll move it over here, and you get that number. So this sub VI will be called to use each time the program executes in the higher level. Okay, so all it does is it takes this output and splits it. One for the, we'll call it the 16 motor eventually, and the 17 motor eventually control. It takes it, turns it from dynamic data into, let's see, what is this? What kind of data is that? That is, what's an orange line? It is not responding. How about right now? Oh, let's move the context. Help. See, it should be telling us this is. Let's try the automatic tool. There we go. Data type of wire dynamic data, and now on the orange one, its data type of wire is scalar. So this little doodad here turns it from dynamic to scalar. Then I multiply it. See, it's only 0 to 5. So I multiply it here by 2 so that I'll have 0 to 10. Then this thing rounds it off, round to nearest. It rounds it off so you have an exact number instead of these scalars that are, decimals. And then I output that. So now if I look at the show connector, this is the available stuff I have to look at. The stop command is run out. Joystick, we're looking at the joystick sub VI. If you click here, you see I'm going to wire out through the connector the stopped light, and then the two outputs. There's one and there's the other. So you got the nice whole numbers. And that's all that comes out of this sub VI. Now here's what the block diagram looks like. I showed you all of it. This is downloaded from QCI, the people that make these motors. They didn't actually write it either. Someone wrote it for them. And this whole thing is to build a string to send to the motors for them to respond. And as you can see, we're set up to talk in with 2 stop bits with a baud rate of 57,600, and then to ask what COM port. So that is run out as a question over here on the front panel, the COM port. And the termination character is 13 and 128 bytes to read. And all of this is built in, and you see I changed the little icon, but here's the connector block. So there's the COM port connector, there's the actual command string you're going to send out, there is the error in and there'll be an error out, and then there is the actual response that the motors come back with. So let's close this. You're going to see that, you see I have one of those here and then another one here. And this is that giant case structure we started talking about earlier. So this feeds in the string that you're going to send to those motors. So now have I talked about all the sub VIs? I believe I have. And then this is the overall program. One other little trick is the stop command. I'm not sure I talked about this already or not. The stop command also comes into a case structure that most of the time, if it's true, it just wires the selection made by the joystick across. But if it's false, it replaces the joystick's output with a 22, which is that instantaneous stop, tells the motors to stop instantly. And then this over here on the left, the continuous steps or discrete steps is what feeds this case structure. So if we, let's see, if we go to the true command, it'll be straight, see the wires are straight across. But in the false, which is if you select continuous, it adds 11. So it's the same exact input, it's just bumps it up to use higher number case structures in these two. And like I said previously, all of these from this case structure to this case structure are identical, with the one condition that these all start with 16, so they go to the motor named 16, and these all start with 17s, so that they always go to 17s. So now let's close this. COM6 here, so it should just run. And right now we're in continuous mode, so the joystick will control the speeds from this being the highest because of the case structures here, this being the lowest. It appears they're not moving, but they actually are. They're just going really slow. Now to go to discrete, we'll click stop once, then go to discrete steps. You need the hand to get that to work. Boink, there we go. And now it's each time it will go in a discrete amount of 4 revolutions. So if you get this dead centered, where both of them say 5, it'll stop. That's actually kind of a game to get the joystick dead centered. Anyways, if they're both 5s, they are stopped. In one direction they go clockwise, in the other direction they go counterclockwise. So between the two you have an X and Y. If this was hooked up to an XY table, you would have control of where that XY table was moving. This is also to show that you can control 2 motors from one RS-232, because RS-232 in this case is multi-drop. So they're sitting there listening for commands sent to them, and they ignore ones not sent to them. So, boonk, hit the stop and they both stop. And that's pretty much 2 motors, 2 QCI motors, being controlled with LabVIEW.